Hello everyone, my name is Lucas Vege. I am a PhD student at UFMG in Brazil, where I am advised by Professor Marco Tulio Valente. In this video, I will present to you the early results of our research on refactorings for the Elixir language. Elixir is a modern functional language that has high performance in parallel and distributed environments. It was designed from a blend of inspirations in other languages. Elixir syntax is based on Ruby. It uses immutable data like Haskell, and the Elixir code runs on Beam, the virtual machine of the Erlang. In addition, Elixir is extensible because it has metaprogramming features like closure. Overall, the popularity of functional languages is on the rise in the industry. More than 300 companies around the world are using Elixir in production code, some of which are well known, such as Discord, Adobe, and Spotify. Just like in any other language, it is expected that Elixir developers seek design improvements for their code through refactorings. Although the popularity of functional languages is on the rise, there are few studies about the refactoring of systems implemented in this language. Furthermore, there is no study yet about refactorings specifically tailored for Elixir. To fill this research gap and understand the problem, we proposed a research question. What are the refactorings reported in the related literature that apply to Elixir? Basically, we searched for refactorings proposed for other functional languages or languages that have influenced the creation of Elixir. Thus, we cataloged the refactorings that are compatible with Elixir. To answer our research question, we conducted a systematic literature review. First, we proposed a query string by combining the terms refactoring, functional language, functional paradigm, Elixir, and the names of languages that influenced the creation of Elixir. We searched for these combined terms in the abstract of papers available in 4 reputable digital libraries, retrieving 124 of them. The abstracts of each of these papers were reviewed by us, and after removing duplicate or irrelevant papers, we selected 51 of them for a deep examination. In a snowballing process, we analyzed the papers referenced by those selected in the previous step, and after reading their abstracts, we selected 14 more papers. After a detailed reading of these 65 papers, we identified 77 refactorings with the potential to be compatible with Elixir code. Finally, each of these refactorings was compared with Elixir's features. 54 of them were really compatible with Elixir and therefore were documented with code examples in our catalog. We classified these refactorings into 3 groups. Traditional refactorings are those based on the well-known Fowler catalog. Functional refactors are transformations that use characteristic features of functional languages, such as pattern matching or high-order functions, for example, and Erlang-specific refactorings use unique features of Beam, the Erlang virtual machine. Due to time constraints, to illustrate our early results, I will present only one of the 54 refactorings cataloged by us. Generalize a function definition is a refactoring in the functional category because it uses high-order functions to transform code. High-order functions are those that can receive functions as parameters or even return functions. When we use functions with equivalent expressions, we can generalize them into a new high-order function. In this example, before refactoring, we have 2 functions with equivalent expressions, full and bar. Both functions receive a list as a parameter and return a new list after 2 transformation steps. Full first squares the value of each element in the original list and then multiplies each modified element by 3, returning a new list. Bar doubles the value of each element in the original list and returns a new list containing only the modified elements that are multiples of 4. In this refactoring, the function generic generalizes equivalent expressions. Note that the bars of the original functions were replaced by calls to this new function. The first parameter of generic is a list that will be modified in 2 steps. All 3 last parameters of this function are anonymous functions in Elixir, indicating that it is a high-order function. Since math operators in Elixir are also functions, we can pass them as parameters to a high-order function. Here, a multiplication was performed, and here an addition. This behavior is preserved by the second parameter. In the second transformation step, either the enumMap function in full or the enumFilter function in bar were used. This behavior is preserved by the third and fourth parameters of the generic function. For more details regarding all 54 refactors of our catalog, I invited you to visit our GitHub repository. In this repository, we provide documentation about all the refactors and illustrate them with code examples. Based on these results, we plan to expand our catalog of refactors for Elixir through a gray literature review, mine code repositories, and engage with the community of Elixir developers. We hope that this approach will enable us to discover Elixir-specific refactors. It was not possible during our systematic literature review due to the absence of published works on refactors for Elixir. In a previous work published by us in the Empirical Software Engineering Journal, we introduced a catalog of code smells for Elixir. Now, similar to what Fowler did in his book, we aim to establish connections between our catalogs of code smells and refactorings, indicating how each code smell can be methodically eliminated. Finally, we intend to conduct a survey with Elixir developers to validate our catalog of refactorings. Stay tuned for news about this work in our GitHub repository. Thank you.